Welcome to the Uptime Wind Energy Podcast. I'm your host, Alan Hall, along with my co-host, Joel Saxum, and we are in New Orleans, Louisiana, of all places, at Gulf Wind Technology. And we have James Martin, who is the CEO of Gulf Wind Technology, and David King, the Chief Technical Officer at Gulf Wind Technology. And first of all, welcome to the podcast, guys.
Great to be here. Yeah, thanks for coming to visit us.
We've had a wonderful time here today going through the Gulf Wind Technology offices and workspace. It is impressive. It's not something I knew we even had in the United States, honestly. And you guys have been working for a couple of years on a variety of different projects and technologies. And we had a meeting this morning, just full disclosure, about all the things that Gulf Wind has been involved with. I'm like, whoa, all right, I didn't know that. Some of it top secret still, some of it not top secret. So, James, let's just start with you. I think people in the U.S. don't have a lot of experience, haven't met you before, haven't worked with Gulf Wind. Could you just give just a brief background on what Gulf Wind Technology is as a business?
Certainly, yeah. Gulf Wind Technology, we are all first principles blades engineers, essentially, first. We've been in the OEM industry for a number of years. We've seen some of the challenges that the industry is up against today. And we like to think that we can predict maybe some of the challenges for tomorrow. So with that team, we've been able to build assets, equipment, get ourselves out there as problem solvers and offering technology solutions to basically problems that can reduce the cost of energy over time. So it gets talked about a lot. We're going to talk about some of the assets we've invested in, but yeah, we've got reliability products that get involved with today, the problems of today's market. We're really passionate about the products of tomorrow, so more performance projects for the future. And we love running projects. So specifically, we've been working in our region to open up or demystify, remove roadblocks for the Gulf of Mexico market, which have got some great technology problem statements in there.
Because that's where we first heard of Gulf Wind, was with the work with Shell.
Gulf Wind.
Right.
Yeah, that's it. Yeah, that's it. It's a double-edged sword.
And we had you on the podcast in a sense because we were talking about the first wind turbine being installed in Louisiana, and Gulf Wind is involved with that.
Yeah, we really thought, because a lot of our challenges about how to get technology to product, how can we demonstrate that we can take it off a desktop study in terms of a solution or an idea, and how can we show it works? How can we de-risk that for our customers? So the first thing we thought is that we really want to invest, put our money where our mouth is, make sure that we can design, make sure we can test on a subcomponent level, make sure we can actually spin anything we're talking about, and demystify some of that technology, essentially.
Well, one of the things Alan and I talk about regularly, whether it's on the podcast or in our many Slack conversations every day, is the fact that there's not a whole lot of technology development, either companies, solutions, services coming out of the United States, right? We know that we are a bit younger of a wind market as a whole than there's our European counterparts, and a lot of solutions come out of it. So some of the performance enhancements, some of those fixes that we're talking about here, like you guys are working on. We're sitting in this, you can see on the camera here, if you're watching on the YouTube version, that we've got blades and we've got a rapid prototyping facility and we've got offices over here and people running around, and there's a lot of things that can go on here because they have the facility built for it. If you haven't looked into what Gulf Wind Technologies and what it can bring to not only the global market, but the local US market, it's huge. It's a game changer for what we should be doing here, and more operators should be coming in here to talk with the team. So with that being said, I know we're in Louisiana, right? What does the rest of the team and the rest of the outfit look like?
So, the core team and where we're founded is really here at the shipyard, Avondale Global Gateway. This is almost the jewel in the crown of former glory North American manufacturing. They used to manufacture giant ships here for the Navy, oil and gas projects. They had 26,000 people here. So this 30,000 square foot facility, it's our true north. This is our headquarters. But we've got an engineering office actually in Hickory in North Carolina. Sort of dead center between Asheville and Charlotte, where our chief engineer and our some of our blade inspection and our loads teams sit. So it's only a few people there, but they really much complement what we're up to here.
Yeah, no, and just as James mentioned, I mean, what we've really done is taken that jewel in the crown and filled it with all the things you need to really understand the problem statements and really dive into the hands-on engineering work that's needed to drive these problem statements into solutions. And so that's really why it's been such a joy to be part of this Gulfwind team, to build this team out, is because we've been able to kind of almost match that kind of handshake between engineering and hands-on work in a very, very real, substantive way.
So you have the engineering resources, but you've got the resources as well. We're in, so everybody knows, I mean, the heat index here in Louisiana, it's like 105 degrees, but it's comfortable, right? So we're in an insulated, air-conditioned facility that is 125 meters long. And if I look through the camera here, I see this is where there's a composite repair testing facility. We have rapid prototyping. There's an actual wind tunnel that you guys built, designed, had calibrated, and are regularly using it down at that end. And so, like, what you would need, like you said, is, hey, not only do we have engineering resources and all the smart people, but we have the capabilities of testing, of, hey, there is a solution. What if we thought about this? Let's action it here. Let's test it out. Let's build a piece and then put it in the test chamber. I mean, we were right over here earlier when we were walking around. Of course, we're recording this sitting at a desk. We're in full PPE walking through here. And there's a material testing station, and snap. We had the energy.
The sweet sound of composite failure.
That's right. That's right. And everybody, we all turned, hey, success, right? So, but those facilities and those capabilities are here. So, as an operator, you have a problem. You say you've got, you name the turbine, XYZ turbine, and we're starting to see this kind of issue in our fleet. Call Gulfwind Technologies. They can replicate the issue with them, get in the field, do the inspections, figure out what's going on, come back here, build what could be, will be the fix, test the fix, and make sure it happens.
And it's really all about getting engineers as close to the problem statement as possible, whether that's sending engineers up tower, having engineers stood around problem statements in a lab setting, or trying to bring the field into the lab to really break these problem statements down and understand them. And so, you know, as you go through that asset list, it's been all about how do we remove these different barriers that we've seen in the past, slow down projects, make things take longer than they really should, and allow us to move quite quickly and rapidly through that kind of prototyping, that fail forward fast type mentality, and get to something where we can actually offer a solution for a customer, whether that's on the performance load side of thing with, like you mentioned, the wind tunnel, or whether it's testing materials, doing subcomponent testing. We really just want to remove these barriers. And as you mentioned a little bit earlier, with the turbine down in Port Fourchon, that's been a huge part of that as well, is what's that top of the testing pyramid where these problems really shake themselves out on these prototype turbines, and how can we in a very quick, rapid, fast way get to that prototype turbine level. We can make blades for a turbine like that in a couple weeks really, which allows us to, again, move super, super fast through these problems.
And being so knowledgeable in blades, the root cause analysis ends up at your doorstep quite a bit in terms of engineering review in the United States. That seems to be a relatively growing business. As people realize Gulfwind is here, they're going to be tapping you to do that kind of work. What kind of root cause analysis work have you been doing lately?
I mean, a lot of what we do is we treat a turbine like it's a production line for energy. So we want to break it down in terms of a very repeatable engineering-based approach to the problem statement. So, you can brand it as whether it's a Six Sigma project and you're breaking it down into those nice steps with gates, or it's a first principles technology development project or a product development project. But we start with the business case. It all starts with that. A customer, what do they want out of our solution? What's their budget for it? What's the time period that they want it both designed and implemented? How long do they want the solution to last for? So once you go through that define stage, it then starts to, you're setting up your design experiments, you're putting your sandpit of engineers together so they can actually innovate. And like David said, kind of fail forward fast, but using all the tools around us to make sure that we're, working with the customer, lockstep with them. We're independent, we've got high integrity. We like to create areas for customers that they can come here. So customers can ship their full blades here. Yeah. And they can do it under very tight NDA terms, totally confidential. If we see a pattern, then we can approach those customers and actually in a very controlled way, cross-pollinate and create more consortia-driven environments, which as we know in this industry, it's sometimes about removing the barriers. And like we were talking about earlier on today, demystifying, getting as close a collaboration between an operator, an OEM, an independent, a field technician, like David was talking about, but creating that appropriate collaborative space to problem solve, and then put a really robust solution together, something that is designed with its end intent, which is no point doing something on a desktop or on a subcomponent level if by the time it's deployed, that's when you introduce the variation. So it's all about de-risking our approach, essentially.
Well, you're just de-risking what you guys do as a company. But in a grand scheme, you're de-risking what the global fleet looks like, right? So people can come here, like you said, operate in, under close NDAs, but if they want to iterate with others, it's available. I mean, right now I'm looking at 1, 2, 3, 4 blades, 4 or 5 root sections. Out beyond this door to my left, there's 8 or 10 full blade sections there. So customers have actually gotten to the point where they say, like, we want to ship you a blade. You guys figure it out. We may send some engineers, we may help out. But when we talk about on the podcast a lot of the shroud of secrecy around everything, you guys have created a facility. Basically, for a lack of a better term, it's an engineer's playground. To come here and solve these problems for the industry.
Yeah, and I think that gets back to the industry need. An operator has a problem with a blade, it's probably not on a blade, it's probably just a series of blades that have a similar issue. A lot of times when an RCA is done, there's an engineer comes out to the field, takes some photos of the blade, they may take a couple of samples, maybe, and then they'll see a report shoved out on the other side, and it doesn't really get down to the heart of what is really causing the issue. And a lot of times, companies that are doing RCAs don't have the mechanical ability to start breaking things apart or cross-sectioning or doing NDA. That's a huge advantage, because if I'm a large operator, I'm going to send you that blade to tear it apart and figure out what's going on, because it's not just one.
It's really about, approaching in that systematic way where whether it's, understanding failure modes, effects analysis, using that as a tool that extracts out what does that teardown need to look like? What do we need to be evaluating here? Is it we need to be doing mechanical testing, looking under the microscope at parts, approaching with a different inspection method, and then ultimately, kind of opening up for a period of time, maybe potentially some different innovative solutions around how you can approach a solution coming out of that RCA. So you're not just identifying that problem, but you're also starting to think ahead on what am I going to do about this problem? How am I going to manage this at scale? How am I going to manage risk? And how am I going to do that at that fleet level? I'd be thinking about that on the onset of the RCA to truly get the most value out of that exercise.
And it's not the really critical part, because when it comes down to it, it eventually becomes a money issue. Mm-hmm. How do I minimize the cost impact and my downtime impact, my business interruption, to get these turbines back up and running so I can get through their useful lifespan? And I think from what we've seen today, Gulfwind Technology has that expertise for sure, but also has a sense of what the business is.
Yeah.
I don't need to extend a blade for another 20 years if it really only has 3 or 4 years of life in it. I need to get it to its end of useful life. That kind of repair is different than the 20-year repair. That knowledge, I think, is really important in how you apply engineering principles to that. So not every problem has the same solution.
Yeah, no.
Time frame matters.
Absolutely, yeah. And that, from our very first problem statement, there was a life extension to get through to repower, as you say, or whether it's one of our more programmatic, opportunities. So with the Shell-sponsored Gulfwind Technology Accelerator, that was about looking actually quite far in the future. That was saying, hey, this is a high-risk environment with specific economic challenges. What does that look like? Like, how are we going to remove the barriers and how are we going to approach it? So we like looking, we look at today, we look at the reliability, and we love applying that to what the future might be.
So let's walk through the hurricane scenario, because this always comes up about the Gulf of Mexico, and Shell anointed Gulfwind to be the company to go look at it. Really, that's what happened, and that's great. I mean, they obviously have done their homework and decided to come here, and that's congratulations on that. But when you put a turbine out in the Gulf of Mexico, there's always a concern in 2 phases. One, that it's essentially low wind conditions, except when there's a hurricane. Then it's super high wind conditions. That requires a different kind of technology or approach to designing blades. And you've been working on that for a little while now. Do you have that solution, or are there multiple solutions? What does that look like? Because we want to put some wind turbines out in the Gulf of Mexico. How does that happen?
Yeah. I mean, from a programmatic approach, and then I'm going to hand it over to David on the blades approach, but from a programmatic approach, it was about the whole ecosystem of wind in the Gulf. So maybe just leaning out from just the blades part for a minute, but we talked a little bit about this. It was about the workforce, the infrastructure, what can be leveraged from oil and gas to actually deploy and take percentage points out of the cost structure in the backyard of the Gulf. And you just have to go down there to realize that. It's a huge production system, you know, and the stats are amazing. You know, the amount of mileage of pipeline, you know,
Platforms,
workforce, cranes, so much stuff that can be transposed into wind. So it was looking at it from that cost of capital, from the economics of wind, from, you know, workforce, training, equipment, deployment, servicing. And then you start to think at the system level, okay, how can the rotor affect the foundation, what the foundation design? And I'll hand the ball to David to talk about more of the rotor and the loads technology part, because that's also pretty damn interesting.
No, absolutely. And as James mentioned, it really has to be rooted in that business case. If you're just looking at things from an engineering problem solving point of view, it's probably actually kind of an easy problem to solve. You can put more material in a blade, you can put more expensive material in it, you can solve the problem. But what you haven't done is you haven't solved the economic problem. So you've got to come into it with an engineering hat on and an economic hat to make sure that you can really deploy turbines in an efficient manner that's going to make that energy competitive in kind of the open market and actually useful for everybody.
Yeah, especially in the Gulf, you're going to be in the ERCOT market. Right?
Exactly.
So that's usually not a fixed PPA, and you're going to be playing with what's going on there. So
Yeah, and Texas side for sure.
Yeah.
No, absolutely.
I mean, there's like there was that Boehm sale off of Galveston, 2 gigawatts or something.
Yeah, and you know, I mean, we've learned a lot about that by bringing parties to the table. So we know our background is blades. We've got the assets to be able to demystify it. But on a programmatic approach, it's about bringing in the experts and actually being quite humble about where are there going to be lessons learned. So we showed you a little bit earlier about where we can. We like collaborating a lot.
Yeah.
So if we can have people that are experts in sighting, ground conditions, deployment, you know, aviation, lightning, birds, migratory patterns. I mean, it's getting all the problems on the table and getting an appropriate size forum where people can talk frankly and not, you know, have a particular lens. And that collaboration piece is
Exactly.
critical.
That's almost part of that optimization problem. You know, if you're, again, putting on an engineering hat now and listening to all those problem statements, how do you find that optimal solution that's incorporating all those different design curves, whether it's a stakeholder management curve, whether it's understanding the economics, the loads, you know, you can boil that down into a lot of different ways. And you want to find that lowest kind of intersecting point between those curves to solve the problem. So with you know, as you mentioned, the Gulf, low wind speed, you've got high loads. How do you solve that fundamental problem, right? That was kind of your original question there. And what it really comes down to is loads management and being smart with your aerodynamics on the front end to be able to drive out the need for materials, drive out the amount of loads that are being experienced by those foundations, and basically selecting airfoils appropriately, selecting your material appropriately, and being a bit creative with how you combine those things together to, without adding cost to that turbine, be able to reduce the load. So it really boils down to a series of technologies that manage those loads appropriately, both from a structural performance point of view, an aero performance point of view, a controller point of view, and then validating that those things are going to work on a demonstration turbine on different scales. And so that's a lot of what the work's been to date.
You're dealing with a lot of blades. Joel and I walked around the facility, and there are a lot of blades outside even, so there's a lot of blade knowledge here. What are the top issues that operators onshore are having with blades at the moment?
Yeah, so I can speak to that a bit. You know, a lot of the issues, you know, are stemming from various types of damage that you're seeing from erosion, which is your typical stuff, your lightning strikes, that sort of thing. There's a lot of problem statements right now around various manufacturing, you know, deviations, quality issues that might have found their way into the field that are resulting in cracked laminates, cracked balsa panel regions, core regions, things like that. And really, a lot of these defects, you know, they need kind of real true due diligence and understanding what's going on with that problem statement. And again, coming back to that kind of understanding the business case for how we're going to deal with these issues. Is it getting something through to repower? Is it getting a 20-year life out of it? Is it getting a 2-year life out of it? And so I guess, it really comes back to understanding these first principle composite problems and seeing some of the similarities that are coming out of that, whether it's a crack in the balsa region, a crack in the root region, a crack in the spar. A lot of the I guess solutions have overlaps, have commonalities between them that you can kind of piggyback off of.
Well, and this goes back to the question of how do I monitor this? So it's one thing to notice you have a crack. The second is, what do I do about it? And maybe the answer is nothing. And we've seen a number of continuous monitoring systems being applied just in that case. And the question from every operator is, how do I know that this CMS system works, or which is the best one, or I have this particular application? Is there a particular CMS system that works in particular better for that kind of problem, that crack problem, or that lightning problem, whatever it is? You're looking at that.
Yeah, it's all data collection at its fundamentals, right? Whether
Right.
you're using a drone inspection, whether you're visually going out and looking at something, whether you're using accelerometers, audible noise, acoustics, any of these different systems out there, it's all about really just trying to capture data in different forms and understanding what to do with those data streams. And so, something we've seen is that each data stream might have a different way of capturing a different damage mode that you're seeing on a blade. Right. So the same solution is going to apply to all damage modes, whether it's an acoustic system or an accelerometer-based system. And so what we have been doing here at kind of the GWA facility is trying to categorize and understand that in a lab setting, and then try and expand out from that lab setting into how do things scale into the field in a controlled way, where you're eliminating noise, you're getting rid of the things that are going to cause variation in that data stream that allow you to not make an actual conclusion off of that. So, for example, one of the things we did is we built a spar box beam in-house and put that at one of our in-house test rigs and put load into it. And the first thing we want to do is actually have no defects, no damage on it. And what do all these systems detect when there's no damage? What's that baseline look like? So we've got comparable data later on. And then we can start introducing defects of different types, different distances from these systems, start to categorize things in a very holistic view, and then start adding the complexities of how do the variables of the field apply over the top of that sort of controlled data set.
And if I'm an operator, I want to be calling David and getting hooked up with that, because I have that problem. Every operator that Joel and I have talked to over the last couple of years,
They all need monitoring of some sort.
Yeah.
every one of them needs a monitor. But they don't know which one to choose. And we provide recommendations because we have knowledge of some of that, obviously, but we don't have direct knowledge.
We have anecdotal knowledge.
Yeah,
We don't have the.
we can tell you it
our
works
own
on.
box beam in our
And there's
phone.
a huge amount of value even in that anecdotal. I think that's
Yeah.
something that, data is obviously extremely important, but also, how is that information being received often plays out in some of those anecdotal stories that I'm sure you guys have worked through personally, where maybe the data was confusing, maybe it gave conflicting signals or things like that. And those are all important considerations.
So, but there's no place to go besides Gulfwind Technology right now. Honestly, where are you going to go in the United States? I know of places that in theory could do it, but you're doing it.
Yeah.
It's up and running right now. You have to start over somewhere else. This is why your leadership in the industry, in the United States in particular, is so valuable, because we're ahead of where I thought we were.
Yeah.
In terms of trying to solve problems.
And a lot of it's about it's like doing a gap analysis. So early on, we worked with the labs. I know you got, NREL and Sandia Labs. They're phenomenal partners. So they're a wealth of knowledge, and they might be able to help us curate what we're going to invest in. Certainly, you mentioned that turning the lights on, doing those blade autopsies. So using the fact that it's a shipyard, it's you've got a mile and a half of Mississippi River next door. We got 35 rail cars can roll onto site. We could have the largest blade in the world wheeled into the factory. There's something that we know we're really proud that that's pretty unique. So, and then cutting it up, polishing it, the racks of samples that we showed you earlier, but, turning the lights on rather than looking around with a spotlight, and again, that's something that we've found is extremely valuable for what we're trying to do.
So, with respect to, of course, NDAs you guys have in place, we don't want to lift anybody's hood too much. But what are some of the other projects that you're working on? Like we talked about the CMS thing over here, but can you give us a couple of them where it's like we're doing this, we're doing this, we're doing this, we're doing that?
Yeah.
Yeah, so just kind of going around the factory, I guess, a bit. We do a little bit of composite manufacturing, whether that's producing parts that can go in the field and be put on a wind turbine. We can actually pre-infuse a lot of parts that find their ways onto blades and solve problems in the field in a variety of different manners. You mentioned the CMS problem statement. We also do a lot of performance characterization. So that involves a rapid prototyping lab where we'll 3D print, scan airfoils, characterize airfoils, understand how erosion impacts performance, loads, a variety of different kind of factors. I think one of the key takeaways or kind of key facts for us coming out of that, the rapid prototyping lab, is the ability to have an airfoil in CAD and turn it around to an airfoil on the wind tunnel in less than 5 days. That's really the real aim of that whole entire facility there. So we do a lot of projects around that. We mentioned a little bit about RCAs. That's receiving blade components, doing blade teardowns, looking at those blade parts under microscope, looking at them when they're on a test stand, putting them underneath NDT in kind of a laboratory setting, a little bit different than sometimes doing that in the field, cutting sections out of them and actually, again, mechanically characterizing those sections as well. And then, we mentioned a little bit about the wind tunnel testing. We do have the wind tunnel here, so we can do a variety of different test campaigns on that, whether that's emerging technologies that somebody wants to validate, or whether it's something that's out in the field right now that someone wants to understand how that's performing. And then kind of the other side of this is actually deploying solutions. So as we speak today, we actually have 2 or 3 teams out in the field. One of those teams is doing up tower NDT inspections. So they're inspecting blade roots up tower. They can do a turbine in about 4 hours or so. So it's a quick turnaround. We can get big deployment very fast with that team. We've got another team that's actually doing repairs in the field today. And they're deploying that repair with some bit of custom kit that we've got, whether it's some custom equipment that we've developed in-house to be capable of going up tower. So taking equipment that maybe traditionally has always been thought of as a down tower solution or a down tower fix, and basically applying composites, carbon fiber, kind of speccing them out so that we can bring them up tower. So that's been a huge element. And then also just some of your more traditional composite repairs in the field as well, where we've got trucks and trailers and fiberglass getting applied to blades. So we can really cover a lot of the spectrum with those projects, and it certainly keeps us busy.
Yeah, when you look at your website, if you like to read, fantastic website.
Yeah.
But it shows I know Alan and I were looking at it before we came down here when we originally had talked with you on the phone, and I was going man, they do this and they can do that and they can do this and they can do that. So, man, okay. What's the next page? They can do this too. They can do that too. So basically, if you have a problem, whether it is leading edge erosion on a blade that you just need fixed, all the way to, rapid prototyping and testing things to the nth degree, you guys can solve it.
Yeah, and we're a young company, and we certainly have been involved with a lot of problem statements, like you say. David talks about some things that are getting deployed, but really specializing in that root region, up tower, repair and life extension. That's something we're really proud of. We've done a lot of work on for almost 3 years now. Just moving into something that can be deployed as engineers intended it to be deployed. So a lot of kind of first principles in terms of lean and repeatability, just making sure that you don't have any risk when you take it out of the tech center and put it into the field.
And a lot of that comes down to kind of the cross-functionality of the team. I think James mentioned earlier a little bit about the North Carolina office and some of the different skill sets around the team. But when we were kind of building out the team, we started out with, almost like an inputs-outputs look on the design of a turbine, right? So we've got site assessments, we've got loads, understanding the loads at the system level, understanding those loads at the blade level, and then understanding the loads within the blade. So structural engineering, composite material engineering, then understanding how are those processes developed, and having process engineers on the team that have got hands-on composite experience, have spent decades in factories building things, repairing things, kind of doing the full spectrum of that side of it, and really trying to bring, again, all that different cross-functionality into one roof so that we're not blind to maybe certain areas of that design where we might be trying to put out a solution or a repair method that isn't taking into account that full spectrum of what else might we be affecting. And that's really where that team plays out quite well.
Yeah, you have a lot of talented people on your team, and to be such a young company to have that lineup of people on your staff is impressive. There's a huge resume behind these names, and that says a lot. As an operator, I want to go to a company that has people that have worked for OEMs, have been in the industry a little while, and understand what composites are and what repairs are and what can go wrong out in the field, which is the problem. I think the big problem is that we do a lot of things engineering-wise that when getting to the hands of a technician that's not familiar with the problem's scope, mistakes are made. And we went through a number of scenarios here that, hey, we're looking at what the technicians could do, taking away the variability of this, or if there is variability, it's not going to affect the overall performance. Those are huge. That's such a huge advantage. Besides, in the repair world, you get a repair instruction sheet and it just says do X. But X rarely happens the way the engineer envisioned it to.
We're having to compliment what's going on at the OEM and the operator level. I think that's what the feedback loop that we get from OEMs and operators, that we're in the right space. We do have a pretty romantic idea of the future in terms of wind. We believe in wind. We've been with veterans of the industry. We know there are cycles. We know there are challenges, but ultimately we've seen innovation get to product. We've seen rotor sizes increase. We've seen quality increase, even though there are sensitivities on quality. We've seen a lot of good, steps forward. It's a young industry in the scheme of things versus some of the other industries we talked about. But yeah, you're right. You need the talent, you need the culture, you need the collaboration, like we've talked about a lot today. So yeah, we're optimistic.
So James, how do people find you on the internet? How do they connect with you?
Okay, so we've got our very lengthy website that we're very proud of. So golfwindtechnology.com. We are trying to get better on LinkedIn about talking about what we're doing in terms of what is out there that we can talk about. And yeah, we really enjoy going to all these array of shows out there.
If you're down in New Orleans, stop by and check out the facility because it is impressive. So James and David, thank you so much for inviting us to New Orleans and to see the facility. It is well worth the trip, and learned a ton visiting with you today. So thank you so much.
Thank you guys, absolute pleasure. Thank you.